In this video, I will assist you in how to prove trig identities. But one of the basic fundamentals of proving identities is to first consider how the question itself is presented. If you have a glance, one look at all these three equations, you will consider and notice something obvious about all the three. You got it right. One glance at all these three equations and you'll see that the equation itself, the density cloud is more heavy towards the left hand side. You'll see this massive equation or this massive structure that is centered or centralized on the left. So our the first step that we have to do is to organize our working so that the mathematical activity will be focused towards your left. So all mathematical equations, they follow one basic principle, and that basic principle is to break down whatever is on the left. As you can see that the equation or the trig identity problem is more heavy towards the left. So it is ideal that our master plan is to try and see what we can do with that very bulky left hand side. So our master plan to break down that trig identity is to focus on the left. We have one analogy, and that analogy is to see that the left hand side is like a brick wall. And our duty as mathematicians is to come in and break down that wall. In other words, we try to dismantle it. So when you solve the problem, you are trying to work like a demolition squad. You come in with your wrecking ball and break down the left hand side into its basic components, so you're able to give the answer which is already shown on the right. But before we proceed into our dismantling process, we need to consider or know what are the building blocks with trig identities. And three of them that normally pop up in any proving identity equation are the three that you already know. Now these are some of the building blocks that we'll have to consider, and they are known as reciprocal equations. And one way to avoid the confusion is just by citing or looking at the third letter, the third alphabet. And you can see here on the screen before you, I've circled the third letter, which is C. That stands that sec theta is 1 over cos, and cosec theta is 1 over sine, and cot theta is 1 over 10. But one handy notation that we need to consider is the expression of tan theta. Tan theta is equal to sine over cos. Now you'll notice that tan theta is also written here. So if I'm able to take this expression, sine theta over cos theta, and substitute it in terms of tan theta, I can get another expression of cot theta. So before we can do that, let us consider this tan theta as a fraction. So if I write down tan theta, the denominator is going to be 1. And that is what you have here. Tan theta over 1 is sine over cos. So what we're going to do is that we are going to flip or invert this tan theta over 1. So whatever I do on the left hand side is mirrored on your right. So if you're going to flip the left hand side, the same activity will also be done here. So that's what I'm going to do. I'm going to flip that. So when that is done, you found the reciprocal of 1 over tan theta, the answer is also done. You'll notice the cos has gone up and the sine has come down. So this 1 over tan theta is the same 1 over tan theta that we have here. So now we can express cot theta in terms of cos theta over sine theta. So that introduces us to another form of cot theta, which is cos theta over sine. There you go. So cot theta is equal to cos over sine. So these are the four basics that we need to understand. 1 over cos, 1 over sine, 1 over tan, and this cot theta. So all of our reciprocal expressions are given there. So you have sec theta, which is 1 over cos, cosec theta, which is 1 over sine, cot theta, which is 1 over tan and cos over sine, and this one here, which is tan theta, sine over cos. So this leads us to the four basic building blocks for trig identities, and I've named it as the Fantastic Four: tan theta, cot theta, cosec, and sec. Now, there is one trig identity. I believe it was introduced to you last year in year 12, and for some of you in year 11, and it is known as the building blocks for trig identities. Can anyone recall what trig identity is that? Good. That's our trig identity. Sine squared theta plus cos squared theta is equal to 1. Now, what happens in this identity? What we are going to do with this identity, we're going to divide the whole thing by sine squared theta through all. And on the contrary, the next step is to divide the whole thing by cos squared theta. And while doing that, we will insert all these fundamentals in pink, and it will come about another expression of this trig identity. So I'll take you through the first and second one. We'll try and do it simultaneously. Now what we'll do, we'll have to divide the whole expression by sine squared. So sine squared over sine squared, cos over sine squared, and 1 over sine squared. And you'll notice that the sine over sine becomes 1, cos over sine, we just learned it a minute ago, cos over sine becomes cot, and 1 over sine is your cosec. So this will come with another expression. Likewise, if we divide the whole expression by cos squared, sine squared over cos squared, it's right up here. Sine over cos becomes tan. Cos squared over cos squared will cancel into 1, and 1 over cos squared gives me sec. So this introduces us to another identity. There, that's our identity. See? So from this first identity that you knew already, and just by understanding the four basic building blocks of reciprocal expressions, you are able to come about these other two identities. Now this is the building block for all proving. All proving identities are based on this. If you know these three, I can refer to them as our tripod. We can tackle any problem for proving trig identities. So today I'm just going to go over the basics on how we are going to play around with these three identities. I can take the cos squared across, or the sine squared across. I can take the plus 1 across, or this plus 1, I'll take it across. So it's all about playing around with these three basic trig identities. So with this identity, sine squared plus cos squared equal to 1, let's play around with it a bit. I'll take the plus cos squared theta. I'm going to take it across to this side to join the 1. So this one I'm going to do the plus. When it goes across here, the plus cos squared will now, what's the opposite of plus? Correct. Opposite of plus becomes minus. So your new expression will look something like this. There. Sine squared theta is equal to 1 minus cos squared theta. And then if you notice, this 1 minus cos squared theta is like a difference of 2 squares. We can factorize that. That's the same as 1 squared minus cos squared. So if you know your basics from Form 4 or year 10, that can be factorized. So if we were to factorize 1 minus cos squared theta using the principle of difference of 2 squares, we will come about another expression of this sine squared theta. The expression of this sine squared theta will be there. Sine squared theta is equal to 1 plus cos theta and 1 minus cos theta. On the other hand, you can repeat all of these steps to make cos squared the subject of the formula. So Here, in this example, we took cos squared. So now you're going to take sine squared. So they will also mirror the same steps that we had followed with sine squared theta. So let's see if you can attempt this. Make cos squared the subject of the formula. Write down the formula first. Sine squared theta plus cos squared theta is equal to 1. Write it down first. And then let's see if you can take sine squared across. Good. So the migration takes place. So in the course of moving the sine squared, what happens to the plus sine squared? It becomes a minus sine squared. So cos squared theta is equal to 1 minus sine squared theta. And like I said earlier, this can be factorized. And when you factorize this, it will give you 1 plus sine theta and 1 minus sine theta. So these are all the expressions. So when the examiners, they set up the formula, other alternatives of sine squared theta plus cos squared theta equal to 1 can be in these three forms: 1, 2, 3. And the fourth one is the one that we just derived recently. So using this same principle, we can also play around with the other identities. So you must have a very sharp eye to see what has been presented. And then we always dismantle that bulkier left-hand side. Remember the principle. It's about breaking down the left-hand side into those minor or building blocks, so we are able to equate it to the answer that's given on the right. Okay, in my next example, I'll show you the second trig identity, which is 1 plus cot squared theta is equal to cosec squared theta. So in this activity, what we are going to do is we'll try and take this cot squared theta across, or leave the cot squared theta, we'll take the plus 1. So we can make the subject of cot squared theta. So we'll take the plus 1 across. So there, the plus 1, when it goes across here, we all know anything that crosses the equal sign will take the opposite of what is on the left. So the plus 1 now becomes minus 1. So there, we've come up with another way in which this identity can be presented. And also this is a difference of two squares. And like the previous example, if we factorize this, if we factorize cosec squared theta minus 1 using the method of difference of two squares, we can come about another expression of cot squared theta. There. So cot squared theta is equal to cosec theta plus 1 and cosec theta minus 1. So this identity that we have here can be expressed in these two that we have here. So finally, in this last identity that we have, you'll notice that we have tan squared theta plus 1 is equal to sec squared theta. Like in the previous example, the plus 1 undergoes the same process. So if we take plus 1 across, we'll come about another expression of this tan squared theta, or this identity. So it gives us tan squared theta is equal to sec squared theta minus 1. And this sec squared theta minus 1 undergoes the same difference of two squares that we've known by now with the two previous examples. So it can be factorized further. And when factorized, it gives us tan squared theta is equal to sec theta plus 1 and sec theta minus 1. That's a difference of two squares. Okay, to summarize what we've learned so far, because by using these building blocks, we can now tackle any problem that they'll ask us concerning proving trig identities. Now in pink, those are the three that we were able to derive. And then from these ones here, we were able to break it down again. Now other expressions of sine squared, other expressions of cos squared, and tan squared, and cot squared. And by going through the previous examples, it was all about playing around with these three. So this comes about one conclusion. I want you to bear this in mind. This is the fundamental of the basics, and you can tackle anything. Whenever, this is my summary. Whenever you see 1 plus or minus something squared, you might be dealing with an identity. You notice here there's something squared plus 1. In this case, there's something squared minus 1. Or 1 minus something squared. Whenever you see 1 plus or minus something squared, you might be juggling or dealing with an identity. So I'd like to leave you with this principle. From here, you are able to tackle any problem. So what I'm going to do, I'm going to go over just 2 basic examples, 2 basic proven examples, worked examples, and that will assist you. Remember, the trig identities, how were they derived? It was by playing around with the trig identities, making the subject of 1, and having an eye of what is on the left, and also considering the reciprocal expressions. And that one there, we were able to iron that out just by looking at the third letter. So let us head now into our first worked example. So in this first worked example, right, you'll see that we are going to work on the left. See how the left is sequenced, the cosec theta and the cot theta. And a minute ago, what was the basic hint? We were able to dismantle or write down cosec theta and write down cot theta in terms of sine or cos. So bear in mind, that is our tip. The basic tip is to break down the bulkier left-hand side. And we can only do that by breaking down this expression for cosec and this expression for cot x. Good. So the third letter is S. So this cosec becomes 1 over sine. Cot x, one expression for cot x is cos over sine. So you'll notice cos over sine, they both have the same denominators. So they can share that denominator. They share the same roof. So sine x can be written once, and we just bring the 2 on top together. So you have 1 plus cos over sine, which is also equal to your right hand side. That's our first worked example. Our second worked example, you can see a very bulky left hand side, and this is equal to 1. Now what did I tell you before? Whenever you see 1 plus or minus something squared, you might be dealing, the probability of you dealing with an identity is very high. So don't forget that tip. Whenever you see 1 plus or minus something squared, or something squared plus or minus 1, you might be dealing with an identity. So look at the identity. 1 plus tan squared theta, this 1 plus tan squared theta is equal to sec squared theta. And we already knew from our previous example, if I make the subject of cos squared theta, if I take sine squared across, 1 minus sine squared is equal to cos squared theta. And that can be substituted here. So this 1 minus sine squared will be cos squared, and 1 plus tan squared is an identity. So using this knowledge, we can now go back to the left hand side. 1 plus tan squared is that identity sec squared, and 1 minus sine squared is cos squared. And the only thing we have to do is to write down, this is a reciprocal expression. Look at the third letter. What is the third letter? You got it right, C. So how will it be expressed? Yes, sec squared is equal to 1 over cos squared. So 1 over cos squared multiplied by cos squared, they cancel each other out. So you're left now with 1. So that's equal to, they cancel each other off. So that's equal to 1, which is also equal to your right hand side. So to conclude this video, my advice to you is to always have an eye of this principle. Whenever you see 1 plus or minus something squared, you're dealing with an identity. And if there's no 1, if there's no plus or minus something squared, but you see acronyms, sec theta, cosec theta, and cot theta, make sure to dismantle the left hand side. I hope you find this video very handy in your pursuit in trigonometry. Be blessed. Thank you for tuning in. Naka.